Hi everybody, it's Kurt and Rob with Two Brothers Hobby, and we're here today with the ZDFly Cessna 421. This was sent over to us from the guys over at Cermark, and it has been morphed into the ZDFly executive aircraft thing.
Yeah, I think that works quite well.
Rob did a little custom paint job on it, so in fact you did the build on this thing. Let's go ahead and hit a couple specs real quick, and then we'll get into all the details. The ZDFly Cessna 421 has a 62.9 inch wingspan. I think you can say that's 63 inches. 62.99.
I'll give you that much.
Okay, 471.6 square inch wing area. The overall length is 54.2 inches. Has an all-up weight of 84.6 ounces. Now, the included motors are two C3542 1100 kV brushless motors with 10x5E props. The included ESC is it includes two 30-amp brushless ESCs, and the recommended battery for this is a 3S 11.1 volt 2200 milliamp. We use something a little bit different, and we'll talk about that in a second. Recommended radio system is a 6+ channel radio system with 5 9-gram servos. Now this does have optional cut-in flaps on it as well.
Correct.
If you go with the flaps, you need a 7+ channel radio with 7 9-gram servos. Now our setup, we went ahead and chose this kit requires a couple things. We chose the Futaba TFG Super transmitter, and we used a R617FS receiver, and then we went ahead and decided to go with Thunder Power 3S 3600 milliamp 45C LiPo. So give us a little bit more run times, and in fact that I think will work out quite well based on what we have. Twin engines can suck down a 2200 milliamp pack in no time flat. So
they can.
A lot of times with the newer cell technology, your compromise of weight is pretty minimal. So if you can get that extra capacity, it's always a benefit. We'll see how it works out. But Rob, take us through the kit as it came out of the box. I know you had to make a couple of modifications on this one actually to get it to work. And in fayou one of the recommendations was from the manufacturer, from Cermark. They said we recommend going this route on one of the changes. So,
all right. Well, as it comes out of the box, we've got it. This would be, I guess, what they would classify as like a plug-and-play model. All the servos were installed. All the linkages were already installed. We basically had to assemble the model, and then equip it with our own radio and battery. But the parts count is not really all that high. It's not a real intimidating model when it comes out of the box. The main work would be the tail surfaces, mainly the horizontal stabilizer, and you have to mount the engine nacelles onto the main wing and mount the wing. But really, it's a very straightforward kit. The instructions were nicely done with illustrations and with text. There isn't any part of this model that's left in the dark, so to speak. It's, like I said, very straightforward. If you've got any kind of kit experience, you'll have no problem putting this together.
Talk to us about the vertical stair, the rudder modification that you did.
Well, the rudder modification, the nice thing about this plane, and unfortunately one of the downsides with it, all of the linkages are hidden linkages. So you have no external linkages as it comes out of the box, which makes for a very nice scale outline.
We've dealt with that in the past, though, where you do compromise some leverage and direct control.
You do.
By doing hidden linkages. A lot of times it's just a lot of force to endure in a very small amount of space. It tends to fall into a torsion category, which doesn't always work well.
On the rudder in particular, Cermark, as a matter of fact, suggested that we remove that internal linkage for the rudder and take the servo out of the way the tail is designed. The servo is completely exposed because the main tail surface comes all the way up to mid-fuse almost as an assembly. And so I took that servo out that they had inside from the factory and did an external linkage. We'll show you some pictures on how we did it. It was really a very straightforward transition or transformation. The problem they were having was with the internal linkage. The linkage itself was fine. The connection to the servo was actually very fine. Where the weak point came in was the rod that came up and bent into the rudder itself in that foam was the weak point. So what they were getting was flutter. Coming out of a high-speed dive or a high-speed pass, they were getting flutter on a rudder.
Which is uncommon to get flutter on a rudder.
It is, exactly.
Compared to the probability of flutter on an elevator or something like that. Yeah.
So with the solid link to the rudder, it eliminated all that. We didn't experience any of it during the flight.
So it's simple as putting a control horn on the rudder and it's relocating the servo and running direct short linkage.
And the way I did it, I tried to minimize as much as possible, so all you had was the linkage itself, not the servo sticking out. And it's a real easy modification. The second modification, and one that probably took the longest as far as assembling this plane, was the front nose gear. Now this does come with electric retracts that operate quite nicely.
With very nice scale details,
yeah,
shock absorbers, and a working oleo.
Exactly. And they really complement the plane and the scale looks of the plane. The problem I was having was when the servo would, or the electric retract on the nose would start to retract, the wheel itself would turn, and the cutout that they provide, it's kind of an odd shaped cutout that they have. It's large at the beginning, but then it follows the profile of the retract basically, which gave it very little room for error. It had to be perfectly straight going up in there, and 4 out of 5 times it wouldn't be straight.
It'd bind up.
It would bind up. So what I had to do was cut the opening, basically the size of the opening at the beginning. I had to carry that all the way through to the end. I didn't have to lengthen it. I just had to keep it one consistent width. And then another thing that I had to do was, as the retract comes up, the linkage has to slide to accommodate that.
Since it's steerable nose. Yeah,
exactly, since it's steerable and it can't bind. Well, the problem it was having was, as it came up, it was turning the wheel.
Okay.
So what I did was, it was a very, very simple modification. I basically raised the rod to the top of the landing gear, and I put just a L-shaped hook and C8'd it into the foam to hold that rod into place.
So
it didn't need to slide up and down.
Is all it was.
That's all it is, a little carrier hook, and it allows that retract to come up perfectly straight now. In hindsight, you may not need to widen the hole as big as I did. I didn't know that at the time. I was trying to get it to go in.
Trial and error, yeah.
So yeah, trial and error, you may be able to eliminate a lot of the foam cutting that I did on the nose just by putting that simple modification in there. But it worked out. Another thing we had to do, which this was another tip by Sir Mark, with the dihedral of the wing, the way that basically the retracts, the pockets that the electric retracts mount to, were put at an angle with the dihedral. So what it was causing was your landing gear to flare out. It was bowing out. And they found after about 2 or 3 landings, you chew the tires completely up. Yep. And then your tracking is just horrible. So what I had to do was put in some brass shims to straighten that landing gear to try to
compensate for the dihedral.
Compensate for the dihedral.
Which leads to us charging up our battery, taking it out and flying it. Now make sure you come back for part 2 for the review scoring.